Good afternoon, class. Welcome to today's class. In today's class, we're going to be looking at addition of vectors. I've already introduced vectors. We talked about the magnitude of a vector. We talked about the size of a vector, that's its magnitude, and then its direction, and so on. And we gave several examples of vectors, and so on. And we talked about the notation also of a vector. And we're going to see more on that, God's willing. So we are going to see today addition of vectors, and how we can find the magnitude of the resultant of a vector. First, what is the resultant? We're going to see that. Okay, now to add two vectors, A and B, you see, this is vector A, and then there is a small arrow on top of A to show that it is a vector. This arrow indicates the sense or the direction of the vector. And then vector B also, the arrow is on it, it shows that it's a vector. If you write the vector without this symbol, it means that it is not a vector. Okay? It means that it is not a vector. So you have to write it without this symbol. But if you want to type it, then you should just write it A without the arrow, but it should be bold. It should be bold. That is how to represent a vector, or that's how to write a vector, the notation for a vector. Okay, so now I have two vectors here. To add two vectors, you must make sure that they both start from the same origin. To add two vectors, you must make sure that they start from the same origin. Two vectors can be added together. Yes, they can be combined together. How do I combine them? You see, this vector has this direction. This vector has this direction. If I want to combine them, I will make sure they both start from the same origin. So for this one, this is its starting point because this is the direction. So I will choose here as a starting point. This is the end point. Okay? Or this is the head and this is the tail. Okay? This is the head of this vector and this is its tail. Its tail is its starting point. So I can choose a point O now. I can choose a point O to start these two vectors. So this one, I can carry this vector B like this. See, that is its direction. This is vector B. See, then vector A is like this. See, and then I have vector E here. See that I can actually put my arrow here like this. Okay, so you see, these are the two vectors. So the next thing I'm going to do, I am going to have a parallelogram around this vector. What is a parallelogram? See, I am going to make this a parallel line of this, parallel to this, on this. Okay, I'll find it. Or I'll use a broken line for that. This is it. I'll use another broken line. So it can be clear. So this and this have the same direction. So this one again, I'll have, see? So eventually, I have a parallelogram. So on this parallelogram, you see these two vectors have the same starting point. I will choose here to be P, R, Q. So P and Q is a parallelogram. We call these the parallelogram law of vectors. But now, how do I get the magnitude of their combination? What is the effect of combining them? If I combine them, to get the magnitude or to get the resultant of these combined vectors, I come to their starting point. This is their starting point, both of them, their origin. So I have it like this. I draw a straight line. This gives me their magnitude, their resultant. So now this is going to be vector A plus vector B. I don't think there is any trouble with this. That's all. That's all you have got to do. That's all. So here, OR is the magnitude of vectors A and B. So now we can now say that here parallelogram OPQR, or let me call it PQR, sorry, this is supposed to be, let me put it in order, let me put it like this, PQR. So here, OPQR is a parallelogram. Meaning that this implies that vector OR, see, I can also write this vector V as vector OR. I can do that with the endpoints here. I can do that. So, see, is equal to vector PQ. They are equal. Why are they equal? Because this is a parallelogram. I do this parallel to this and so on. So that's it. And OP is equal to RQ. See, I am using my arrows here. Be consistent in that. Use your arrows. If you do not put this arrow, it means that it is not a vector and you're going to fail. So you have to put your arrows to show that it is a vector, okay? So this is vector OP is equal to vector RQ and so on. So the next idea is to be able to write this, see? Therefore, hence, OR, vector OR, the resultant is called the resultant. Let's just say vector OR is called the resultant of vector A and vector B. See, that's it. That is called the resultant of vector A and B, and so on. Okay, another example. Consider the vectors. Consider, again, let me take this out. Or before I give another example, let me quickly state something here. It is not necessary to always draw a parallelogram here. We can see that this is equal to this. They are equal. Because they are equal, I can, instead of leaving it like this, I can write this one. You see, this one is also a vector. Can you see? So I can just take this one to form a triangle, which is simpler. Instead of having the parallelogram, I can just make it a triangle, which is even simpler. So it will contain everything I need. So one is going to start at the end of the other. See, this one is the starting point and this one is the end point. This is tail, this is head. So here we have tail, we have head. So two vectors can be combined thus. I can say where one starts and ends. So this one is starting here, O, is its starting point and ends at P. See that? This is vector A. This is vector A. Then the other vector can start on the head of the other one. Sorry, let me just do it like this so it will be clear. Sorry? It will be clear. I can just do like this. See? I can say this is the head of the vector. Can you see that? I'm taking this triangle OPQ. See? So this is P, this is O. And then this is the tail of the first one. And then this is its head. See? So I have a vector like this. This is tail, head, tail, head. So you combine them this way, one on the head of the other, okay? They are both actually starting from the same direction, but to have their combined effect, you're going to have one starting at the head of the other one, okay? Or on the head of the other one, so here. Now this is my resultant. This is my resultant. This is vector A. This is vector B now. And then this is vector A plus B. This is how we deal with vectors. So now in our next video, this is P, please. This is P. This is point P, and this is point Q. So in our next video, we are going to see how to combine many vectors into a single vector in our next video. Okay? Thank you.